The Atlas case was designed to not only protect the customer's safety and property, but to also protect the longevity and the capacity of the battery itself. The case itself is consisting of two separate layers. There is this outer layer in yellow that you can see here that is consisted of 1045 carbon plate steel. And then inside the case, after I finish moving this, you see that we have a separate box that is green and blue, which consists of grade 2CP titanium alloy plate. Now, the reason why the container itself is separated into two separate layers is to ensure that this innermost layer right here containing the titanium box can create an artificial environment around it where basically we seal off the actual container holding the EV unit and we create an artificial climate around it. The bottom of the case will be lined with these carbon steel support beams on the four corners of the case, and then in order to make it more mobile and portable, I've added these longer carbon steel hollowed bars that will be where the forklift will be able to pick up the case itself and lift it onto the different transportation vessels. The actual climate control system itself is going to be controlled here through the Raspberry Pi that we implemented on the outside of the case. As you can see here, there are aluminum bars covering surface wire that lead directly to the plug-in to the Pi that are coming from sensory information coming from temperature sensors here, from moisture sensors on the outside of the box, and from temperature sensors on the inside of the box that will basically be giving input readings to the Pi and telling it whether or not it should activate one of the two climate control systems, or if it needs to activate the emergency protocols for if there is a runaway fire happening. As a power source for the Pi, we have set up a lithium-ion battery that we've attached to the side of the case, leading directly to the Pi. There are DC voltage options that we can hook up to the Pi that will make it compatible with this type of electrical setup. This makes it portable and will also make it easier to replace any power supply problems in case the Pi decides to fail. The case itself has two separate mechanisms to control the internal temperature of the inside of the case. The first one is when the case is when it's in an outdoor environment that's too cold or is starting to diminish battery capacity. That is when this electric space heater mounted to the inside of the steel case will be activated. As you can see here, there are surface wiring that's still covered with more aluminum bar through a perforated hole to get to the outside. And then the second part, which would be to keep the inside of the case's internal temperature from being too hot, would be to activate, there would be a series of fans on the outside of the box here, and as well as here, that will draw air into the container and push air out, keeping stagnated air from building up in the box. And then when the outdoor temperature is too hot for the case to operate, that's when the fans itself will shut off, and these blocks of PTFE plastic will be moved along to seal the case itself on both sides with using motors that are connected here to the Raspberry Pi, which is why, again, we're using a motor board for the Raspberry Pi to use. Now, in the event that all of these precautionary measures have failed, the climate control system has failed, or the anti-impact system has failed, that is where the Atlas's true features come into play, which is its emergency response system. So inside the case, we have 31.5-inch tall cylinders that are 7 liters each, filled with argon gas that has a lime particulates that have been pulverized mixed into the gas, where basically at the end here there would be a pressure control valve that would be operated by the Raspberry Pi that said that basically in the event that the temperature sensor inside of the case picks up that there is a rapid increase in temperature over time, indicating a fire, that will launch the emergency protocols, which will automatically seal the inside of the box and will begin to release the gas from inside of these cylinders, which will neutralize the acidic HF gas and any other toxic gases that start to build up inside of the titanium case. The theory here being that if we can basically keep the concentration of the acidic gases from building up to too high a point by flooding it with this gas, that we should be able to prevent a catastrophic failure. In addition to the high melting point of titanium, which rests above 3,000 degrees Fahrenheit, the inside of the titanium case will be coated with a substance known as aluminum oxide, which is a ceramic substance that has a melting point of above 3,700 degrees Fahrenheit. This makes it resistant to the thermal pressure that would be exerted on it by the runaway reaction that might occur from a battery igniting. In addition to this, the inside of the steel shell will be coated with a substance known as PTFE, which is a special type of plastic which is not only resistant to heat up to 500 degrees centigrade, it is also corrosive resistance, which means that any toxic gas that might escape from inside of the titanium shell that was not neutralized by the mixture of argon and lime would be basically trapped inside here, unable to break through the lining of that.